All right, so I want to do a video on the program break, and I was messing with trying to make dynamic memory in assembly, and there's different ways to go about it, and one of the ways is to move the program break. So if you don't know, when you make dynamic memory, it's stored in the heap, and um, I think from what I understand is the memory in the heap can be stored from, low address to high address, and I think the stack goes from high address to low address. Uh, I could be wrong about that, but I'm pretty sure, I think that might be the case. Don't take my word for that. um, but yeah, I think the heap gets stored from low address to high address. So the program break is like, I don't know, it's somewhere in between the stack and the heap. It's like right here. So wherever the heck it is. And I think initially, I don't think you even have anything. I think it's probably initially probably lower down. I'm just taking a wild guess. I'm still learning, so don't take my word for all this stuff. So what I did was, if you take the sys break, so this is the an RAX for the syscall. If I supply it with the number 12, that's the system break. Here I can get system call. If you look at uni std, yeah, see that's 12 right here. So yeah, that's what that is. And if you apply it was, if you take the first argument and put a 0 in the first argument, in RAX it returns where the program break is at. And otherwise, what you want to put there is the new address where you want to move the program break, whether it be up or down. And if I want to allocate memory, I want to move it up towards the higher address so that I have more room. So right here I have a function just called func for allocating memory and filling that memory with some type of data. So the two arguments for func is, the data, which is data1, which is just hello, and then the length of the data, which is 6. So then, in the function I have a size and a data local variable, and then I take, the first argument, put it in the .data local variable, the second argument, put it in the .size local variable, and you notice how I kind of move the address of RDI into RDI and then put that RDI into data. That's because it's a string, and you know that strings are char pointers. I mean, char pointers and not just chars. So that's kind of what I did. That, like, if you think of C, a string is a char pointer, and then a character is just a char. So because of that, that's why I did that. So here I'm allocating the memory. When it initializes, the init function I kind of have right here, it, we see that we get the, like I said before, where the program break is in RAX. And then I put that in memp. I probably could have called it program break, but I just called it memp. That's the name I was thinking at the time. So I take memp, put it in RAX, then I take that value, add the size we want to allocate, put that in RDI, and then that's saying, that's telling the sysbreak system call where the program break is now going to be located at. So I'm moving it from, a location down here, and I'm moving it upwards. Maybe it's like here now, I don't know. So I can get my eraser just for visuals. Wow, I'm terrible at scrolling. I could say that I moved up a little bit. BRK. And then I'll just do a different color for the old one, I guess. Brown, why not? old VRK. So yeah. So I moved it up more, giving me more room in the heap. And then once I did that, I moved the original, starting address, which was right here. I wonder if I should have done that. Well, no, because the memory is going to grow upwards, so that's fine. So I took the original starting address for the heap, and I put the data into RDI, and then I put the data into the original starting address. That's what I did. I had to think through what was happening there. So I took the data that I have, which is the hello, and I put it into the original starting address. So this brown area at the old BRK equals what? Let's make this a different color, I guess. Why not? Not white, because that's the background. Blue? Data 1. So old BRK equals, my handwriting is terrible with my mouse, data 1, which is hello. And that hello, so all of this space from the old program break to the new program break is that data 1 variable. So yeah, whoa, I scrolled. And I can just show you this in GDB real quick. Just to get a visual of what's going on, I'll just compile it, GDB, break at func, run. And we're in our function, and this is the part right here where we assign a value to that new program break. So I can actually print off where the program break is now if I do XSX and mem p. We see we get, this is where the program break is before we allocate the memory, or before we move the program break. So I keep moving, and I'm going to keep going until I get to, where's that at? What is that, 6A? So I'll keep going until I get to 6A. And then let's print off what's that RBX, and then I can actually print that as a string. And we see that this is the starting address we seen earlier. If we look at memp right here, it's 405000. We see that's what this is right here, and we see that we have the address hello, and that went successfully. Also, if I do a info process mappings, see that we have the starting address for our program, for our heap right here. We have the starting address and we have the ending address, and that's technically not the address. It's actually this plus 6 because I only moved it down by 6. So if I did a find 0x 405000 and then did the same thing, just added 6, and then I tried to search for that string hello, it should tell us where the string is located at. I think I added a terminator character. Yep, and it says it's found, and it said it found it at here, which is the starting address. So yeah, and then I can just continue, just delete all the breakpoints, continue, and the program exits successfully. So yeah, that's just a little bit about breaks. I could be wrong about how this works, but I think I did it right. And hopefully you learned something.